3, 2, 1, start. Hello everybody, how are you doing? I am so excited today. We're going to look at the triangular numbers, and I tried to limit my excitement, so I have 3 facts for you. I wanted to pick a whole lot more, but I had to limit it and say, okay, let's just focus on 3 really cool things about the triangular numbers. So let's figure out what the triangular numbers are exactly. I'm going to start with the first number. All right, it's a set of numbers, and the first one in the set is just 1. All right, so I'm going to say that my first triangular number, I'm going to say T1 is just 1. And I can represent my first triangular number with just a single dot. All right, the second number, T2, is going to be 3. And 3 can be represented like this. Okay, see how this doesn't look like a triangle, but this second number starts to look like a triangle, right? T4, all right, T4 is going to be 6, and this can be represented as another triangle. Look how it's kind of building off of the last one. Oh my gosh, this is T3. Okay, the fourth triangular number, I'm sorry. The fourth triangular number is going to be 10, and guess what? We can represent 10 as 10 dots, and here is a little triangle that you can make out of them, all right? I'll do one more. The fifth triangular number, we're going to call T5, is going to be 15, all right? And here is my triangle that represents this number. All right, there's my dots. So these are our triangular numbers, and I could keep going on and on and on, okay? So what exactly am I doing to get from one triangular number to the next? Well, here you see I start out with 1, and then I have 1, and then I add 2, all right? And then I've still got that 1 in my third triangular number. I still have that 1, I have the 2, but now I'm adding 3 in, all right? So you see how I'm kind of adding up a whole bunch of consecutive numbers. This first one was just, again, 1. This next one was 1 plus 2. The next one is 1 plus 2 plus 3. And the next one we can see is going to be 1 plus 2 plus 3 plus that last row now of 4, all right? And then the fifth triangular number we could say is 1 plus 2 plus 3 plus 4 plus our last row of 5 now. Let me add in that 5 there, and you would get your triangular number of 15. Okay, if you watched my last video from last week, it was assignment 6.2, you'll recognize that, hey, in all of these, I'm just adding consecutive counting numbers, right? I'm adding all these consecutive natural numbers, and we figured out a formula for that, right? So our formula, if you remember back from that, was let me get a different color. Our formula was n times n plus 1 divided by 2. So, and here, again, I have another visual for you, right? So our first triangular number, T1 is 1, T2 is 3. Again, see how these triangles are being formed. Our next one, T6, is going to be 21, all right? Again, to get from that last one, I just added on a set of 6 dots towards the bottom. They all make these cool triangles, all right? So let's test this formula out and make sure it still works for our triangular numbers. So let's say I want to find, let's test it with our 6th triangular number. So if I want to find T6, I would input n equals 6 into here and say, all right, 6 times 6 plus 1 divided by 2. All right, that's going to give me 6 times 7 divided by 2, and 6 times 7 is going to be 42 divided by 2, and that will be 21. And that checks out with our 6th triangular number. You want to test one more maybe? Let's do, move this off to the side. Let's do T3. Let's find the third triangular number using our formula to test it out. I know that it should be 6 here, but let's make sure we do actually get 6. So using that formula now, I'm going to say n equals 3, and I can plug in My third triangular number should be 3 times 3 plus 1 divided by 2. And that's going to be 3 times 4 divided by 2. 3 times 4 is 12 divided by 2. And then 12 divided by 2 is 6. And hey, we got 6. So that checks out. All right. So these are our triangular numbers. Very cool. And we have a formula to find the nth triangular number, right? So if I wanted to find the 35th triangular number, you could plug in n equals 35 into this formula right here, and you would find the 35th triangular number. So let's get started with the facts, because I'm really excited about these facts. Fact number 1, all triangular numbers have a digital sum of either 1, 3, 6, or 9, all right? Again, these are just fun little facts and cool little party tricks. I think they're really interesting. So, all triangular numbers have a digital sum. Let's define what that means, actually. The digits of a number, so maybe you have a number 301, all right? My digits here are 3, 0, and 1. So the digital, let me make sure I spell that right, digital sum of 301 would be 3 plus 0 plus 1, which would give me a digital sum of 4. And my little fun fact here says all the triangular numbers have digital sums of either 1, 3, 6, or 9. So again, we're going to test this out. I have my triangular numbers here in a little chart. All right, here's my first triangular number, T1, my second triangular number, 3, T3 is 6, T4 is 10, all right? So these are all my triangular numbers that we just talked about, and I kept going in this table here, so you can see even some more triangular numbers. Our digital sum, again, it's the sum of all the digits in that number. So here with my triangular number 1, the first one is just 1, there's only one digit, it's 1, you add up 1 by itself, it's literally just 1, okay? And that checks out. Okay, and then the next one, 3. Again, there's no other digits to add together, so it is just 3. And then 6. Okay, here, 1 plus 0 is just 1. All right. 1 plus 5, for my fifth triangular number, the digital sum, 1 plus 5 is 6. For my sixth triangular number, I'm going to have a digital sum of 2 plus 1, which is 3. The next one here, I have 2 plus 8, which is 10. But still adding those numbers, right, 1 plus 0, that gets me a digital sum of 1. This next one, a digital sum of 3 plus 6, which gives me 9. So, does this fact either check out? Are they all either 1, 3, 6, or 9? 1, 3, 6, 1, 6, 3, 1, 9. Yeah, this is pretty cool. So, all triangular numbers have a digital sum of either 1, 3, 6, or 9. Pretty cool. Okay, let's move on to fact number 2. Fact number 2, if t, again, I'm using a variable here because it could be any triangular number. If t is a triangular number, then 9 times t plus 1, all right, 9 times t plus 1 is also a triangular number. So let's test this out and see if it is true. So here's my little check. I'm going to check with the first triangular number, t1. So this fact is saying, and I know that t1 is equal to just 1, right? So we're going to keep that in the back of our pocket. It is saying that if t1 is a triangular number, then 9 times t1 plus 1 is also a triangular number, all right? So I know that t1 is just 1, so I'm going to substitute into this little formula here with 1, and I'm going to get 9 times 1 plus 1, and that's just 9 plus 1, which is 10. Is 10 a triangular number? Yes, it is the fourth triangular number. All right, that's pretty cool. Let's try the second one. Okay, so I know that T2, the second triangular number, is 3, so it's saying that 9 times T2 plus 1 is also a triangular number. Again, I'm just going to substitute in this value into my little formula and say, all right, 9 times 9 times 3, got to make sure I'm using my triangular number. 9 times 3 plus 1, and that's going to be 27 plus 1, and that equals 28. Is 28 a triangular number? Yes, it is. All right, you can look back at that list if you'd like. Pretty darn cool stuff. So 9 times any triangular number plus 1 is going to give you another triangular number. Pretty darn cool. Okay, here's my last fact. Okay, the last fact here, it says that the sum of 2 consecutive triangular numbers is a perfect square. And I had an explanation point because that's super cool. So let's break this down real quick. The sum, okay, that indicates addition. The sum of 2 consecutive triangular numbers. Consecutive means like one after a number. So consecutive numbers 1, 2, 3, 4, 5, 6, right? Those are all consecutive. In our list of triangular numbers here, 2 consecutive numbers, if you add them together, they're going to be a perfect square. What exactly is a perfect square number? Well, if you squared any of your numbers, right? So like the first perfect square would be 1 squared, which is equal to 1. The second perfect square would be 2 squared, which is equal to 4. The third perfect square would be 3 squared, which is equal to 9. You see this here. So here are all of our square numbers. 1, 4, 9, 16. The next one would be 5 squared, which is 25, 36, 49, ... All right. So it's saying that the sum of 2 consecutive triangular numbers is going to be one of these numbers listed off to the right. So let's check that real quick. Here are 2 consecutive numbers. They come right next to each other, right? So 1 plus 3, if I add those together, gives me 4. Is 4 a perfect square? Yeah, it is, because 4 is equal to 2 squared, right? So this fact looks like it's going to check out. 3 plus 6. Again, these are 2 consecutive. They're right next to each other. 2 consecutive triangular numbers. If I add those together, I'm going to get 9. And is 9 a perfect square? Yes, it is, because 3 squared is equal to 9, all right? 6 plus 10 is 16. Again, that's in our list over here. 10 plus 15 is 25. 15 plus 21, 36. 21 plus 28 is 49. And then this last one, 28 plus 36 is 64. I mean, I could keep going if I listed out more triangular numbers here, right? But these are all, oh, hang on, the 4, 9, 16, these are all perfect squares from our list. So that's also pretty cool. There's a lot of different things with our triangular numbers. Okay, I'm going to ask you a couple questions that are going to be based off of this, but I want to show you one more really cool thing. This guy, Blaise Pascal, I'll write his name out here, Blaise, and it was in French, so I'm not 100% on that pronunciation. Blaise. Anyway, this guy, mathematician from France. He was French. He was from France, and his dad was a tax collector. So, fun fact about him, he actually invented like the first digital calculator, and I will post a link on how these things work because it's pretty cool. Basically, you used it like a rotary phone, so you would enter in the digits of the number that you wanted to add based on like the position of these little notches of these little wheels here. And he was pretty cool. So anyway, Pascal, one of his things that he's really famous for is Pascal's triangle. And I really hope that maybe we can do another one of these videos on Pascal's triangle, because there are seriously a ton of things about Pascal's triangle. One of the cool things I'm going to show you real quick is along this triangle here, okay, along the edge of it is a whole bunch of ones. The second layer, okay, here, 1, 2, 3, 4, 5, these are all of our counting numbers, all right? And then the third layer, I'm going to use this in green. Look at this. 1, 3, 6, 10, 15, 21, and it's going to keep going because this triangle, it goes on forever, and I'll show you how to do that later. But this 1, 3, 6, 10, 15, 21, hey, those are our triangular numbers. So the triangular numbers are also kind of hidden in Pascal's triangle. I love this one. Math is just It fits perfectly together. It's a nice brain exercise, and it gets you thinking. Okay, so information about Blaise Pascal. We talked about 3 facts. Let me cover them real quick. Again, the sum of 2 consecutive triangular numbers, 2 triangular numbers that are next to each other, is going to be a perfect square. If you have a triangular number, if you multiply it by 9 and then add 1, that is also a perfect, or I'm sorry, it's also a triangular number as well. And then here, the digital sum of any triangular number is either going to be 1, 3, 6, or 9, all right? And again, this was how we represented our triangular numbers. Ugh, I love combining math and history. It's super interesting to me. I hope this was enjoyable to you as well. What I'm going to post is going to be a bunch of other like cool resources if you want to check it out. But really, I'm asking you to watch this video and then complete the assignment. It's going to be another fun one. All right. So have a great day, and I will see you later. Go team.